that says let the set D equal the set E, which is the set containing -2, -1, 0, 1, and 2. Explain why the following statements are true. Part A, for all x in D, there exists a y in E such that x plus y equals 0. So we're making a universally quantified statement about all of the elements in D. So let's start with picking -2. So is it true that there exists a y in E, which we're going to use green to pick? And keep in mind, E and D are the same sets. So can we find a number in this entire set such that the sum of the two numbers equals 0? And the answer is yes. So in this instance, -2 is my x and 2 is my y. So we've checked that the statement is true for when x equals -2, but we have to check all 5 of these numbers. And so let's now pick -1 for x. And if x equals -1, then we would pick 1 for y to show that the statement is true, because -1 plus 1 is 0. Now if x is 0, then we would pick 0 for y, since 0 plus 0 equals 0. And then when x is 1, we would pick -1 for y, and when x is 2, we would pick -2 for our y. And so that's why part A is true. We've checked every single element in D, and for each of those elements, we found an element y that makes the statement true. For part B, that says there exists an x in D such that for all y in E, x plus y equals y. So the first quantifier here is an existential quantifier, which means if we want to show part B is true, then we need to just simply find one object x that's in D that makes the statement true. Now, how can we find that x? Well, that's part of the game in mathematics, is to create your own heuristics for finding instances in which a statement is true. We know that the statement is true, so if you want to find this x, we can just simply pick each of these objects in the set and see if the statement is true for all elements in that set. So if we pick -2 for x, then we can check, is it true that for all y, x plus y equals y? Well, if we pick -2 for y, is it true that -2 plus -2 equals -2? No. So this is not true for when x is -2. So this means that x cannot be -2. What about -1? Well, let's check if for all y in E, x plus y equals y. If we pick -2 for our y, then x plus y is -3, which is not the same thing as -2. However, if we pick 0 for x, you'll notice that it doesn't matter what we pick for y. If we add y to 0, we're just going to get y. So -2 plus 0 is -2, so that's true. So that means x plus y equals y. 0 plus -1 is -1. 0 plus 0 equals 0. 0 plus 1 equals 1, and 0 plus 2 equals 2. So the reason why part B is true is because we can pick x to be 0, and that means that x plus y equals y. Thanks everyone, and I'll see you in the next video.